All right, this is the second lesson in this unit, rational exponents. So here's just a review for exercise 1. So if we have 2 cubed to the 4th, that's a power to a power, so you are going to multiply your exponents. Okay, B, same thing. We saw that the same rule will hold true even if they are negative exponents. So multiply your exponents again. That's going to be 5 to the negative 10th. This one, you have a power of 7 to the 0 power. So that's going to be 3 to the 0, which if you want to, you can simplify that to 1. Even D, even though you've got 3 powers here, it's still that power to a power. So you would be doing 4 to the 2 times negative 2 times 2 power. So that would be 4 to the negative 8th. Okay, now we're going to use some of these rules to look at exponents that are fractions. So if we look at 16 to the 1/2 power, so if you do 16 to the 1/2 squared, so that's a power to a power, so that would be 16 to the 1/2 times 2 power, or 16 to the 1st. So now the question is, what other number squared makes 16? Okay, so I can square a power of 1/2, okay, and that'll give me 16, or 4 squared also gives me 16. Okay, so another way you can think about that is 16 to the 1/2 power is the same thing as the square root of 16. Okay, so we're going to use that same idea that this exponent of 1/2 is the same thing as saying the square root, and then you can check these on your calculator. So 25 to the 1/2 power, that's the square root of 25, or 5. Okay, so again, you can get on your calculator. You all have the graphing calculator app, so you can do 25. You can use your caret, and in parentheses, you can say just 1 divided by 2. That works just fine to represent that fraction. Okay. All right, so 81 to the 1/2. So we're going to say that's the square root of 81, which is 9. Okay, 100 to the 1/2, square root of 100 is 10. Okay, and again, you can check those on your calculator, and you'll see that that holds true. Okay, so here is a generalization that b to the 1 over n power is the same thing as the nth root of b. And again, we had already looked at this concept last unit. Okay, so here just reiterating that. Okay, so we can rewrite these using a root. So 125 to the 1/3. So this would be the cube root of 125. Okay, now we can use a factor tree if you wanted to check this. So 5 times 25, this 25 is 5 times 5. Okay, so you can see cube root of 125 is going to be 5. Okay, 16 to the 1/4 power. Well, that's the same thing as saying the 4th root of 16. Again, if we use a factor tree, we can break this down. Since it's a 4th root, you need 4 of a kind to make a group, and you've got 4 2s that you can make a group. So 4th root of 16 is going to be 2. Okay, so 9 to the negative 1/2 power. All right, so negative exponent, we know that's going to, we could do a reciprocal. So we could think of that as 1 over 9 to the 1/2, or 9 to the 1/2 would be the square root of 9, and that would be 1/3. Okay, 32 to the negative 1/5. So same concept here. We can do the reciprocal to take care of that negative exponent. This would be the fifth root of 32. If you do a factor tree on 32, you're going to have 4 and 8, and you're going to end up with a whole bunch of 2's. So this is 2 and 4. That 4 is 2 and 2. So you end up with 5 2's. So this is going to be 1/2. Okay, again, we had already kind of talked about that, so hopefully that is familiar to you. All right, so what if instead of just like a 1/2 or a 1/3, what if we have something like 3/2 as an exponent? Okay, well, we could think of this as 3/2 as being 4 cubed and then taken to the 1/2 power. Because remember, power to a power multiply exponents, so 3 times 1/2, that would be that 3/2. Okay, so then if we evaluate this, so 4 cubed is 64, and then if we take that to the 1/2 power, well, remember 1/2 power means square root, so square root of 64 would be 8. Okay, so then this one, what if we think of this another way? So if this exponent is 3, I need 3 times something to get the 3/2. Well, that would be 4 to the 1/2 power. So again, you have the 1/2 times the 3 gives you the 3/2. So if we simplify this, well, 4 to the 1/2. Okay, so that means square root of 4, and then it'll get cubed. So square root of 4 is 2, and then cubed, and 2 cubed is 8. Okay, so you can write those exponents either direction. So the first time we did it cubed and then to the 1/2 power. This time we did 1/2 power and then cubed it, and you get the same answer either way. Okay, and then C, you can verify that using your calculator. You can do your 4 cubed, do that, take it to the 1/2 power, and so on. Okay, so this one, 27 to the 2/3. So we can do the same kind of thing. So whichever way you want to write it. Now we can use one of the methods that we did above, or we could kind of combine those. So another way you can think about 27 to the 2/3 power would be the cube root of 27 and then square it. Well, cube root of 27 is 3 squared, and you'll get 9. Okay, so here is kind of that rule then. So if you have a rational exponent like m over n, then that's going to be the nth root of b to the m. Okay. Okay, so same thing here. So 16 to the 3/4 power. So that's going to be the 4th root of 16 and then cube it. 4th root of 16, you can do your factor tree. It's going to be 4. You're going to have a group of 4 2's with none left over. So this is going to be 2 cubed or 8. Okay, 25 to the 3/2 power. That's going to be the square root of 25 and then cubed. So square root of 25 is 5. 5 cubed, 125. 8 to the negative 2/3 power. Okay, so let's take care of the negative. So let's do the reciprocal. 1 over 8 to the 2/3. So this is going to be the cube root of 8 and then square it. So cube root of 8 is 2, and then we're going to square it. We get 1/4. Okay, now one way to kind of think about this, if we go back to this rule, is if you have a rational exponent, the numerator of that exponent becomes the exponent. The denominator of that exponent becomes the root. Okay, so when we rewrote 16 to the 4/3, notice that the denominator became the root, and the numerator became the exponent. Okay, so maybe that'll help you keep track of what needs to go where.